Welcome everyone to the week 3 tutorial for the NPTEL course Programming Data Structures and Algorithms in Python. So for this week's tutorial, we'll be taking three problems. Problem 1 will be multiplication of two matrices using Python. So if we are dealing with the matrix of order 2 cross 2, so then we can simply say that, let us say there are two matrices which have element like A11, A12, A21 and A22, and we want to multiply it with another matrix of the same order, let us say B11, B12, then B21 and B22. So this multiplication is pretty much straightforward. What we would be doing, we will be multiplying elements of this row with elements of this row and adding them together. Then we'll be again multiplying with element of this row with element of this row to get first and second element. So first element would look like, so let us say this is 1, this is 2, this is 3, this is 4. These are outputs. So O1 would look like A11 into uh, A11 into B11 plus A12 into B21, and O2 would look like uh, A11 into B12 plus A12 into B22. Similarly, for O3 and O4, we'll be multiplying second row of matrix A with first column of matrix A to get O3, and second row of matrix A when we'll multiply with the elements of second column of matrix B and add them together, we'll get O4. So basically, first I mean here it is simple when when we are dealing with the matrix of lower order, but as this order increases, the multiplication uh, gets more difficult. So for now, I'll just erase this so that we'll have space if we want to write anything more. Okay, so now if we want to multiply the matrices of larger order, let us say the order m cross n, where m and n both are large numbers, and we want to multiply it with another matrix that has order n cross b. Remember, if we want to multiply the matrix A with B in the given order, so by saying in the given order, I mean we'll be taking multiplication A into B and not B into A, because if the matrices are not square, then if A into B is possible, then B into A may not be possible. So we need to be careful that uh, in case of matrix multiplication, that the number of columns of matrix A should be equal to the number of rows in matrix B if we are calculating A cross B. And if we are calculating B cross A, then the number of columns of matrix B should be equal to the number of rows in matrix A. So in this case, the number of columns of matrix A is equal to number of rows in matrix B. That is why A cross B is defined and B cross A is not defined, because number of uh, number of columns in matrix B is not equal to number of rows in matrix A. So now let's look at the convention that we have used here for the elements the matrix. So let us say when we are calling A11, A12 and A11 or A21 to AM1 or AMN. So basically A11 represents that this element is residing in first row and first column of matrix A. Similarly, the element A1n, it basically specifies that the element is in first row and nth column. Similarly, AMN specifies that element is in uh, mth row and nth column. So this is the standard, terminology that we are using here for the indices of the elements. And similarly, we have defined a matrix B, which has uh, p number of columns and n number of rows. So now, if we want to multiply them, then let us say they produce a matrix C, which looks like which would be having a dimension that is p number of columns and m number of rows. And by this multiplication, we can see here, when we multiply a matrix of order m cross n with matrix of order n cross p, we get another matrix of order m cross p. So the same terminology for the element is followed here, and based upon the terminology, we can get the we can calculate the every element of matrix C by using this formula here. So what this formula says, that Cij would look like AI1 into uh, AI1 into B1j plus AI2 into B2j plus AI3 into B3j plus plus uh, as the number of columns in ARn and the number of rows in B are also n, then is this would be like AIN into BNJ. So basically, this is how we'll calculate each and every element um, in our multiplication matrix C. So basically, for first element, I and J will be 1, 1, 1, and our formula will look like A11 into B11 plus A12 into B21 plus A13 into B31, and so on. So, and the example for that we have listed here. We can simply look that C23 can be given by, because C23 will be resulted from the multiplication of second row of A with the multiplication of second row of A with the multiplication of third row of B. So basically here somewhere we'll be having third row. So third row of B. So multiplication of these both will give us C23. So remember that when we are multiplying the elements in a particular, in let us say ith row in A with uh, jth column in B, we get and sum all those, or sum all those multiplication, we get a Cij element. So we do not get the whole row, we just get an element, and then we need to keep on proceeding the process to get other elements. Let us say in this particular column, C21 will result from multiplication of uh, second row of A and first column of B. So similarly, C22 will be second row of A and second column of B. Similarly, C23 is second row of A and third column of B. So this is how we would be calculating, the elements in the matrix C. So now, how would we proceed this using Python? So basically, in Python, we can use the list comprehension approach, which actually looks a one-liner solution to the matrix multiplication in Python. So here, the complete matrix C can be calculated using this particular this particular script in Python. So I have divided it in three parts for your better understanding. So this particular parts. So when we do first iteration in matrix A to get A row, and first iteration in in matrix zip in matrix in zip star B. So what does zip star B does? So let us say we have a matrix. Let us say the matrix B, which looks like um, 1, 2, 3, comma 2, 3, 4, comma 5, 6, 7. So let us say this is what it looks like. So when we do zip of star B, and we try to print all those, we try to print those elements one by one. So let us say we simply say for I in zip star B, and we try to print all those elements, we'll get elements something like 1, 2, 5, 2, 3, 6, and 3, 4, 7. So in a sense we will be getting column of this matrix in one iteration, one column of this matrix in one iteration. So basically this looks like this here. And then in second iteration, we'll get the second stack, which is this, and third iteration, we'll get the third stack. So which originally is the column of matrix B. And as we remember in our formulation, that to get a particular element, we need to multiply a row of a matrix A with a column of a matrix B, and sum all those multiplication of the elements, and we'll get the element of matrix C. So with in first iteration we'll get one row of matrix A in the first iteration of this particular for loop. We'll get the first column of matrix B, and when we iterate over them, we get the respective ij's, we multiply them, and we sum them together to get a particular element in that with respect to that particular row of matrix A and column of matrix B. Now, when we include this portion, so after first iteration of this, first iteration of matrix A to get the row, we complete all the iteration of matrix B. So essentially, we are multiplying the element of a particular row of a matrix A with all the elements of matrix B, and then summing them together. So this is how we'll get a column of a row of matrix C corresponding to that particular row of matrix A. And then when we iterate over both of them, we are going to get the complete matrix, all the rows and columns of matrix C. So we are essentially doing, we are just following the mathematical steps that we have discussed, and we have tried to write it in terms of Python syntax. So now we will try to see how it would look like uh, in our Python interpreter. So yeah, so here we can see that so basically this is the syntax for the first problem. So we are defining a function called matrix multiplication. We are supplying it to matrices, matrix A and matrix B. Now we are asserting a condition, which is an important condition here. We are suggesting that the columns of matrix, the number of columns of matrix A should be equal to the number of rows of matrix B. So in this case, we are calling it matrix 1 and matrix 2. So number of columns of matrix 1 should be equal to number of rows of matrix 2 if we want to do a matrix multiplication of matrix 1 and matrix 2 in the order. So now if this assertion fails, it should return that matrices are incompatible for multiplication. So, but if it passes successfully, then it should return the syntax we have already seen. So for first row of matrix 1 and first column of matrix 2, it will calculate the first element of matrix C. But if we iterate over the rows of matrix 1 and over the columns of matrix 2, we are going to get the whole matrix. So whole matrix after the multiplication. So let us say here we are going to uh, we have chosen these two matrices. So matrix 1 is of order 3 cross 3, whereas matrix 2 is of order 3 cross 4. That is, it has three rows that we can see. This is first row, this is second row, and this is third row. And length of this first row or second row or third row represents the number of columns in the matrix. So here in this case, the multiplication between matrix 1 and matrix 2 is possible, whereas the multiplication between matrix 2 and matrix 1 is not possible. So we'll run this function definition, and then we'll try to compute the multiplication between these two matrices and check what output we are going to get. So first of all, we will be seeing what output does it give if we are multiplying matrix 2 with matrix 1. I mean, so in the order matrix 2 multiplied by matrix 1. So we'll see what it returns. So this is actually online Jupyter notebook kind of platform on deepnote.com. So I'm just it is starting up. It takes some time, and then we can you know we can keep on running our programs and everything. So yeah, it's okay. So it's ready now. So we'll see what the matrix multiplication of matrix 2 and matrix 1 produces. So yeah, so it has produced the matrices are incompatible for multiplication, as we had uh, as we had doubted. So now we'll see what the multiplication of matrix 2 and matrix 1 produces. So matrix multiplication of matrix 2 and matrix 1 has produced this output here. Uh, so I mean, we can this is just a 3 cross 3 multiplied by 3 cross 4 matrix. So you can simply check the output of those multiplications, and we will look at the another approach to uh, you know solve the same problem. So in this approach, we'll not be using any list comprehension, whereas we'll be using the nested for loops for the same, and we'll see um, how it is going to work out. So you can see that the matrix 1 matrix and matrix 2, we have chosen the same matrices, so it should produce the same output. So here again we are asserting the same condition. So if this condition is not met, the program will be terminated. But if this condition is met, so then we are initializing our result matrix with all the entries as 0. So first we are iterating over row, and then we are iterating over um, columns, and as we have already seen that the output of multiplication of matrix A and matrix B will have the same number of rows as matrix A and the same number of columns as matrix B. So that is why we are for rows we are iterating over the number of rows of matrix A, and for columns we are iterating over the number of columns of matrix B, and then we are placing zero for each and every element. So this is how we are getting a zero zero result matrix. So in a way we are initializing the result matrix, and then as the computation progresses, we will be replacing those zeros with the actual value of the multiplication matrix. So now, as in if you remember in our formulation, Cij was given as Aik multiplied by Bkj. So we will choose a particular row of a matrix A, and then we will be multiplying it with a particular column of matrix B. And the the multiplication, basically this multiplication will be summed up over the number of columns in matrix A, or number of rows in matrix B. So for that, we are we are starting our iteration, or we are starting our for loop with number of rows in matrix 1, and then we are starting we are nesting another loop with calling number of columns of matrix B or matrix 2, and then we are running a loop over the number of columns of matrix B or matrix 2. So here again we can see that it has three indices. So first indice is number of rows in matrix. Uh, I mean, I mean it counts for it accounts for the row of a matrix A. Then it accounts for the column of a matrix B, and then it accounts for the number of rows of a matrix B or number of columns of matrix A. So that is why the three loops are coming in here that are nested, and then our result basically will be calculated as per this relation. So that is uh, uh, we are choosing particular row of matrix A and particular column of matrix B, and then we are summing them up with another iterator that accounts for the number of rows of matrix B or number of columns of matrix A. In this case, it's A stands for matrix 1, B stands for matrix 2. So now if we run this particular script, then we are going to get our output as, so output looks same. If we compare, the output looks same, and this, so the we can follow either of the message. The list comprehension, I think it has not been covered in the course yet, so it will be covered in upcoming lectures. So it would be nice if you already have some taste of how it works, and then it would help you to understand much better. So and for the purpose of whatever you have learned till now, you can follow this particular program rather than using the list comprehension if you are not comfortable with list comprehension till now. So now we'll be moving on to our next problem, that is, okay, so next problem is we want to calculate the monotonic trend in a given non-parametric data, or basically this monotonic trend was given by sense, so it is called sense slope. So now what will I first I'll try to make you understand what is the monotonic trend in the data. So let us say we have a motor manufacturing company. So it produces, sorry, so let us say it has some number of outlets in a city that sell those motor products. And here, let us say we have this time axis, and we say that every month so many vehicles are sold in a particular outlet. So let us say this is a you know this is a plot for um, a particular outlet. So for a given outlet, let us say in a first month they are selling these many vehicles, in second month they are selling these many vehicles, third month these many, in fourth month these many, fifth month is many, then 6 months, then 7 months, then 8 months, then 9 months. So if we look at this data, so if we join all the point, it would look something like this. But overall, if we try to look, it would have some increasing trend. So we had started with some point. So uh, at this point, the number of vehicles sold were very less, and then we in next month the number of vehicles sold has increased. Then in next month it had decreased a bit, and then it suddenly shooted up. So I mean, we can see that over the months there are various positive trends and negative trends, and so the data has mixed trends if we look at month by month. But if we want to look at the overall trend in the sales of motor vehicle in a particular outlet, so we can see that the overall trend is increasing. So there can be a possibility that uh, another sales outlet, so for which the number of sales might have decreased, so the overall trend in the data would be negative. So this would give company an idea that this particular outlet is performing better as compared to, so basically outlet 1 is performing better than outlet you know than outlet 2. So uh, I mean, so this is the importance of monotonic trend in a statistical sense. So we'll not go deep into about the sense slope here. Rather, I have uh, I have um, rather I have given this link. So if you are interested, you can follow this link to to get the idea about what is a sense slope and how it is calculated and the statistical significance and everything. But for now, how whatever we have learned, it is sufficient for us to proceed forward just for the calculation of sense slope. So, so basically, sense slope, the definition of sense slope follows that we would calculate the slope for we would calculate the slope between each 2 points. So let us say we'll start with this point and we'll calculate the slope between these 2 points, then these 2 points, then these 2 points, then these 2 points, then these 2 points, these 2 points, these 2 points, and with I will calculate the slope between point 1 and all other points. Then we will calculate the slope between point 2 and all the remaining points, because with point 1 we have already calculated. Then we'll calculate the slope with point 3 and the remaining points. So this is how we'll be having slope between all 2 points, all the combination of 2 points in this particular in this particular data set. And the slope should be calculated in a forward manner, like when you are calculating slope called yj minus yi divided by j minus I, so j should be greater than I, and then we will be calculating the median of this slope data set, or the slope list that we have calculated. So that will return us the sense slope, I mean, of that particular data set, or it would tell us whether the trend of the data is statistically or monotonically increasing or decreasing. So now, but for the definition of median, you may not be aware of the definition, or you must have heard about it. So if you're not aware, basically, so if the list has odd number of members, so let us say A1, A2, A3, A4, and uh, A5. So let us say these are odd number of terms. So um, basically, if n is odd, so the n plus 2, n plus 1 by 2th term would represent the median. So in this case, A3 would represent the median. Whereas if we had, let us say, let us say uh, A1, A2, A3, A4, A5, and A6. Let us say there are six members, so which are even number of members. So if we see these two are the middle members. So the average of these two, that is A3 plus A4 divided by 2, would give us the median. So this is the definition. So now, first of all, we'll calculate the slope between all the points in the data set for the given condition, and then we will sort them in an ascending order to calculate the median. So basically, in this particular week, you must have learnt about various sorting techniques. So we'll use search and sorting techniques. So we'll use one of the techniques to uh, sort the data, and then we'll calculate the median to get the monotonic slope in the data set, or called sense slope. So we can, so Python syntax for the same would look like, uh, so first of all, we will be, uh, so basically this definition, what it does, it calculates the, I mean, it using the insertion sort technique, it sorts the data in ascending order. So as we can see that in the definition, it takes the input as a list. So it is the list of number that we want to, uh, we want to sort. So we need to be careful that this particular data is numeric. So if it is non-numeric, so we can assert a condition, or we can return a warning that the data should not be non-numeric. So I mean, we have already seen that how to assert that warning, and return that warning and terminate the program. So I am not going to all those things again, but so for that you can look at the videos of last week, how we can do all those things. So now we'll do the insertion sort. So uh, we will be saying, okay, we are choosing each and every index in the list, and then we will initiate the index, and we'll check whether this index is greater than 0, and then we'll also check whether whether the element in that particular list corresponding to the index I is less than the element in the list corresponding to index I minus 1. So if list element of the index I is lesser than the element of the index I minus 1, we will switch them switch them together, and then we'll check this for all the elements, and this is how our data will be sorted um, in ascending order. So this you must have already seen in the classroom as well. So now we'll proceed to the definition of sense slope. So now for the sense slope, we will, as we have already discussed, that we need to create a list of all the slopes between all the combinations um, of all the combinations of the 2 points in the data set, and then we will try to calculate the slope between those 2 points. So for that, we will initiate a loop. We'll say, okay, for I in range length of list, and then we'll use another nested loop. So it is a nested for, we'll say, for j in range I plus 1 length of list, because we have already seen in our formula that the formula stands, that is yj minus yi divided by j minus I, provided j should be greater than I. So this way, whatever j we are going to choose, it will always be greater than I. So then we will append all the slopes that we are going to calculate using the given formula. So actually we are following this particular formula to calculate all the slopes that we can calculate using the members in the data set, and then we will sort sort the elements of the slope list. So the slopes that we have calculated, we need to sort them in an ascending order so that we can calculate the medium and get the monotonic slope, whether it is ascending or descending. So if if the if sorry, it's increasing or decreasing. So if the slope is positive, then we would say the data has a monotonically increasing slope, and if it is negative, we'll say the data has monotonically decreasing slope. And that is that you must have seen in your basic geometry classes, that y positive value is a positive slope and negative value gives a negative slope. So we'll not go into those things, but then if we have already sorted our list, then we will check whether the number of elements in the list are even or odd. If they are odd, so this will be returned. If they are even, this would be returned. And we have already seen how actually this works. We have already seen the formula, and that formula is actually written in the form of Python syntax. So now we want to we want user to input the list, and then we would uh, we would convert the list in in the desired format, and then we'll pass it through our formulation sense slope to get the monotonic trend in the data set. So we will first run this portion. We'll first run this sorting function, then we will be running this sense slope function, and then we will be running this function. But remember, whatever the values we are going to input, those should be comma separated, because we have created a list of the input by by splitting them with comma. So uh, so let us say we are going to put in values. So first we'll start with a very simple, very simple list. So it is 1 comma 1. So over the time, the value of the value of y is not changing. So that's the idea. So it's intuitive that if the value of I is not changing, the monotonic trend should be it should be 0. So it should neither be monotonically increasing nor be decreasing. So if we do that, we have got it to be 0. So remember that after splitting this list, whatever we input, whatever user inputs, actually it is converted to the string, to a string. And when we are separating it in terms of a list, basically it returns a list of strings, not an integer or a slope. So what we need to do is we need to convert all those elements in the float form, so that we are able to do the algebraic or arithmetic operations. So now we'll check again. So it was intuitive. If the value is not changing, it should be monotonically in constant. It should not be increasing or decreasing. But if, let us say, we are increasing by 1 bit every time, so one number every time, so the slope is comes out to be +1. What if we are decreasing? So let us say 9, 8, 7, 6, 5, 4, 3, so on. So okay, so I think we have made some mistake here, but no issues. Yeah, it's 10, 9, 8, 7, 6, 5. So I'll just press enter, and it would return a slope to be -1. We can also look at more uh, more chaotic data. So let us say -100, comma 70, comma 53.69, comma 90, comma -4, comma -9, comma 10, comma 53, comma 68, comma 74, comma 8. So if we try to calculate the trend, this comes out to be decreasing trend, because as you are moving forward, maybe the values are uh, in general decreasing. So uh, so overall trend actually comes out to be negative. So we need to be very much careful while inputting the data from the user, because whatever you give as a input, so you are assuming that you are giving input as a integer or float or complex number, but when it is processed in Python, it is converted into a string. So this we have already seen, and we have seen some more methods to uh, convert uh, convert the input data into the required format. So, next problem, or the last problem of the day, is, so in this problem we want to calculate the ratio of multiplication of elements across the column, and multiplication across a diagonal of a given square matrix for all the columns. So as a output, we want a matrix. So let us say we have a matrix A. So it has, this is first row, second row, third row, fourth row. This is our first column, second column, third column, and fourth column. This is actually our diagonal. So the diagonal basically separates the upper triangular part of and lower triangular part of matrix, in symmetrical number of elements, because this is a square matrix. And this is essential condition that we have already specified. The matrix should be a square matrix. If matrix is not a square matrix, our function output should return a warning or error, and it should terminate uh, instantly. Because the if even if we are doing computations and then we supply the condition that it should be a square matrix, then the computations will go in vain. So we need to be careful about that. So now the intended ratio is, we for a first row we multiply A11, A21, A31, A41, and then divide it by A11, A22, A33, A44. And for second row we need to multiply A12, A22, A32, A42, and then we should divide it by A11, A22, A33, A44. And similarly we should do it for column 3 and column 4. So this is how we are going to get our four required elements. So I mean, this is the idea. We need to uh, we need to try to I mean, compute um, these elements of matrices. But one more thing we need to be careful about: if the any term in the diagonal is like A11 or A22 or A33 or A44, and either of them are let us say 0, then it should terminate the program, because such ratio is not even defined. So we need to be careful about that. We should provide it as a condition in our program. So we'll see how actually it looks in Python. So for that, we'll go to the syntax of our program. So as we have already discussed, an important condition must be inserted, that uh, the matrix must be a square matrix, that the number of rows in a matrix should be equal to the number of columns in the matrix. So if this condition is not passed, then it should give us an insertion error called input is not a square matrix. So but if it passes, then we will calculate the multiplication of diagonal terms. So we will initiate with um, we'll initiate an intended output variable, that is diamult, I'm calling it here. We are initiating it with 1, because if we were to calculate the intended output with summations, we would initiate it with 0, but our intended output is calculated with multiplications, hence it will be initiated with 1. So we will initiate, or will start the iteration using a for loop. So we would start the iteration, that is, for I in range, you know length of matrix. So we need not to, we can either initiate, we can either iterate over the row, or we can iterate over the columns, um, because we are interested with this, because for this multiplicative output we are interested in the terms in diagonal. So terms in diagonal are basically a11, a1, a22, a33, and a44. So if we are iterating over the, let us say we are iterating over a row or a column, so the both numbers are same. So when we would define a term, we would define an element. So that would be defined as matrix I. So basically, if I is equal to 0, it would return element 0 comma 0 0 0. So, or if I is equal to 1, it would return 1 1. If I is equal to 2, it would return 2 2, and so on. So this is how it would calculate the diagonal multiplication. And if diagonal multiplication turns out to be 0, then it should simply return that the ratio is not defined. It will not do further computation, and it would terminate the program by returning this message. But if that diamult is not equal to 0, then we would initialize with a required ratio list. So we are initializing this list because we want to append the elements that we are going to compute as the ratio of the multiplication of a particular column element to the dia multiplication to the multiplication of a diagonal elements. So for that, we will start the computation along, or we will start the iteration along the number of rows. So for I in range, length of matrix, so that is the number of rows. Then we will initiate the call multiply equal to 1. Now we are initializing it under the iteration, or under the for loop for number of rows, because, and before the number of columns, because we want to uh, we want this call multiply to reset to 1 after the computation for a particular column. So when all the columns are computed, it should reset itself. Then for the next row, I, I mean for I mean when the uh, as we have discussed, when the computation or when the multiplication of all the elements in a column has already calculated, and already calculated, then we should append it to required ratio list, and then this call multiply should reset to 1, and then again for next column the computation will occur, and then further it will be reset, and then this loop will keep on going until all the computation for until the computation for all the columns are completed, and then it would return us the required ratio list. So we have tried to implement this idea in terms of a Python syntax, and we'll see how well it works. So here we are supplying a matrix that is 4 cross 4, and then if we try to compute, we'll get the required ratio. Now if we want to change the change the question to multiplication to the ratio of multiplication of the elements in a particular column to the multiplication of diagonal elements, then we can simply exchange this I and j. So basically then this j will go to this j will go here, and if when this will go here, then the multiplication of all the rows will be um, multiplication of all the elements in a row, in a particular row, will be computed. So I mean we can understand it here. So let us say we want for let us say for let's we'll try to first understand for column 1. So for column 1 it should look like a11, a12, a13, a14. So here if you see that uh, sorry uh, it's that is for row, actually it's a11 into a21 into a31 into a41. So basically here we can see that the column uh, column indice, it remains constant because we are computing a multiplication of elements in a particular column. This row indice is actually changing. So that is why we have changed this particular indice in I mean it, while calculating the element of required ratio list, we have changed this particular element in case of column 1, but in case of row 1 the multiplication should look like a11 into a12 into a13 into a14. So basically the row indice is remaining constant, whereas the column indice is changing, and we need to uh, and this is how we compute the multiplication of all the elements in a particular row. Hence if j will be in this place, it for a computation of a particular element in a required list, this will be iterated, and the row indice will remain same. So that will be I in this particular case if we want to do computation for the rows in place of columns. So I mean, so we have seen these two problems related to matrices. So we should be focusing on um, playing with the indexes of a matrix. So because it's very helpful in numerical computation, in all the numerical computation techniques, you would be playing with the matrices or matrices kind of um, things. So if you would learn to do good with different I mean different operations using using playing uh, with the indices, it would really helpful in your application for various numerical computations or other areas of work. And one problem that covers this uh, that covers this sense loop. So the idea was to implement the insertion sort that we have learned in our classroom, and we have just tried to implement it to one of the real life problem that we may be interested in. So it's one of the important statistical indice that may be meaningful when you are working with real data. So this is all for